Pair of linear equations in two variables. In today's lesson, we will learn about pair of linear equations in two variables. Have you ever wondered how we can find two unknown values using two different equations? This concept helps solve real-life problems involving age, speed, distance, shopping, business, and many other situations. Let's begin our journey into one of the most useful topics in algebra. A pair of linear equations becomes a system of equations when both equations contain the same two variables, usually x and y. Instead of solving one equation separately, our goal is to find one pair of values that satisfies both equations simultaneously. Foundations. This common solution is called the solution of the system. Finding this shared answer is the main objective of this chapter. What is a linear equation? A linear equation is an equation in which every variable has an exponent of 1. There are no squares, cubes, square roots, or products of variables. Because of this simplicity, every linear equation represents a straight line when plotted on a graph. That is why these equations are called linear equations. General form. The general form of a linear equation in two variables is ax plus by plus c equals 0. Here, a, b, and c are constants, while x and y are the unknown variables. Most linear equations can be written in this standard form, making them easier to solve using different methods. Where solutions live. Every linear equation represents a straight line on the coordinate plane. When two such lines are drawn together, the solution is simply the point where they intersect. This graphical approach helps us visualize algebra. Instead of just numbers and equations, we can actually see the answer on the graph. Three possible outcomes. When two straight lines are drawn, three situations are possible. First, the lines intersect at one point. This means there is exactly one solution. Second, the two lines completely overlap. In this case, every point on the line satisfies both equations, giving infinitely many solutions. Third, the lines are parallel. Since parallel lines never meet, there is no solution. Method 1. Substitution. The first algebraic method is the substitution method. First, solve one equation for one variable. Then substitute that expression into the second equation. This converts two equations into a single equation with one variable. After solving for that variable, substitute the value back into either equation to find the second variable. This method works especially well when one variable is easy to isolate.
Elimination. The second method is the elimination method. Here, we make the coefficients of one variable equal. Then we either add or subtract the equations so that one variable disappears. This leaves a simple equation with only one variable. After finding its value, substitute it into one of the original equations to determine the second variable. This method is often faster when the coefficients can easily be matched.
Method 3. Graphing. The third method is the graphical method. Draw both equations on the same coordinate plane. The point where the two lines intersect gives the solution. The graph also tells us immediately whether there is one solution, infinitely many solutions, or no solution at all. Graphing provides a visual understanding of the system. Summary of methods. No matter which method we use, substitution, elimination, or graphing, the final answer should always be the same. Each method simply provides a different path to the same solution. Choose the method that makes the problem easiest to solve. Example using substitution. Let's solve an example using the substitution method. The equations are 7x minus 15y equals 2, and x plus 2y equals 3. First, rearrange the second equation. We get x equals 3 minus 2y. Now substitute this expression for x into the first equation. Simplify the equation carefully. This gives y equals 19 by 29. Finally, substitute this value back into the second equation. We obtain x equals 49 by 29. Therefore, the solution of the system is x equals 49 by 29, and y equals 19 by 29.
Example using elimination. Now let's solve another example using the elimination method. The equations are 9x minus 4y equals 2000 and 7x minus 3y equals 2000. Multiply the first equation by 3. Multiply the second equation by 4. Now both equations have the same coefficient for y. Subtract one equation from the other. The y terms cancel. This leaves x equals 2000. Now substitute x into the original equation. After simplification, we obtain y equals 4000. Therefore, the solution is x equals 2000 and y equals 4000. Let's summarize today's lesson. We learned what a pair of linear equations in two variables is. We understood the standard form of a linear equation. We discovered the three possible outcomes when two lines are drawn. We explored three important methods of solving these equations: substitution, elimination, and graphing. Finally, we solved practical examples using both algebraic methods. These techniques are widely used in mathematics, science, economics, engineering, and everyday problem solving. Thank you for learning.